Engineering 305. This is the quiz for week 14. I think everybody knew it. This was a problem out of the book. Beam is loaded and supported as shown in figure 8.172. Find the reaction forces. It might have been a good one to go, hey, what's the deflection at L over 2? But if you got the reaction forces, the rest of it, we can do the rest of it. Especially because if you've got the reaction forces, then I would say you write the integration equation for that first section, which is only based on the reaction at A. There's no moments at A, so it's only on the reactions at A. That's the only, and then whoop, done. So it becomes pretty easy. Pretty easy. But let's plug on here. You know what I'm going to do. I think you know what I'm going to do. Get that out of the way, and I'm going to redraw. Oh, I'm going to try to redraw this, but my screen isn't working right. I've got that load. I've got this situation, and I can't change my pen color. There we go. And a distributed load across the top. And the first thing I'm going to do is I'm going to change that. I'm going to transform that to being a simply supported beam. A simply supported beam with a load at the bottom and the middle and a distributed load on top. And the reason I do that is because that is going to break down into these two loading conditions. And those I can look up on my table. Those are loads, situation 6 and situation 7. Now, the really nice thing about, and this is why we get to use 6 and 7, is we're looking for the deflection at the middle point because my boundary condition that I'm going to apply is delta, and I have to be careful here because that length is 2L, and this length is L. And the reason I have to be careful is when I say delta at L, normally I would be thinking of delta all the way at the end. No, it's delta in the middle is equal to 0. And that's equal to the sum of the deflections from the two things. So if I look at this, okay, pull up that equation, load case 7, it's minus 5WL to the 4th over 384 EI. Okay, I'm gonna minus, and that's, yes, because I got a load from the top, minus 5 divided by 384 W, and I have to be careful how I write this, so I'm going to put L in quotes to the 4th over EI, and I'm going to do the same thing over here. I've got, what's that equation? Well, simply supported beam. I've got to pull up my equation again. That's load case 6 minus PL cubed over 48 EI, but that's if the force is going down, my force is going up, so it's a positive. Turn those off again. So it's plus P, and maybe I ought to put P in quotes, L in quotes, cubed over 48 EI. And the reason I want to put those P in quotes, and maybe I can put the W in quotes too, is because we have to substitute in. Now, the reason the W didn't get quotes is because W equals W. L is equal to 2L. Anything else I got to know? But those are, and that's for both cases. All right. So 0 is equal to minus 5 384ths W 2L quantity to the fourth over EI. And I'm going to write this a little bit differently. 1 over 48 EI. P is actually the reaction at B. That's why I wanted to put that into quotes. And then it's 2L cubed. And now I'm going to start simplifying. So that means I'm going to, by simplifying, I'm going to move that across to the other side. I'm going to collect my various terms. And so I'm going to get, oh, I don't want red. So angry. 5 over 384 W, and I'm going to drop an, I'll put it in there, 8L to the fourth. Sorry, that's where I made my mistake before. 16L to the fourth. 2 to the fourth is 2 times 2 times 2 times 2, which is 4 times 4, which is 16. I got to put my EI in. EI-E-I-O. Equals 1/48 RB times 8L cubed over EI. There you go. Now, let's start simplifying. So the first thing I'm going to do is I'm going to get rid of an L EI. I'm going to get rid of an L cubed. And I'm going to move my fractions over to the other side, all my numbers. So I've got 5 divided by 384 times 16 is over there. And then I'm going to put a 48 over there, and I'm going to put an 8 down there. And I've got that moved, this 48 and that 8. And everything else is gone. So it's RB. So now I just have this nasty. It's not terrible. I've just got this fraction I got to deal with. And I hate to say it, but I screwed this up so many times. But now I know how to do it because somebody told me you just punch it into a calculator and it tells you what it is. Oh, that's just dirty, rotten scoundrel. But what I do know, actually I'm going to pause because I got to double check this, but I believe 48 is going to go into, does it go right into 384? Hold on, let me check. At least 24 does. Yeah, 48 goes into 384 8 times. So I'm just going to take that and that. I'm going to put 8. And that makes sense because 8 times 4 is 32 plus the 64. Yeah, okay, I could have done that. And now I can start crossing stuff out. That and that cancel and give me a 2. And then the 2 and the 8 give me a 4. And what I'm left with is RB is equal to 5/4. Oh, you know, I missed a WL out here. WL. That's right. It's right here. WL. And that's the correct answer that if I look at my beam and I go back, 5/4 WL. And I should put my distributed load here. Now I want to solve for the rest of it. I want to solve for the reaction at A. And that's a good thing to do. So I just do sum of the forces in the y direction are equal to, well, I've got the force down. What's that force down? Well, many of you might have thought it was WL, but the distance of the beam, remember, is 2L. So that's W times 2L, and then I've got a plus 5/4 WL, and then I've got a plus reaction at A plus the reaction at C. Well, the reaction at A and the reaction at C, this is a symmetric system, so they're the same. So I've got 8 force WL. Oh, sorry, that's a negative. Minus plus 5 force WL. So that gives me 3 force WL plus, and I'm going to just call it 2RA minus, you guys aren't helping, is equal to 2RA, or, sorry, that would be, since I moved it across to the other side, that became a plus. Let's do this correct here. Plus, and that's a minus, is equal to 0. So RA is equal to RDC is equal to 3/8 WL. Lot of little algebra typos. Yeah, got a pounding headache, so that's the best I could do. There you go. RA, RC, and RB was right there. There's my reaction forces. Hope you're doing well. See you soon.